Hello there, this is Gil. Today we're going to continue discussion of arrays and loops. And as a refresher, this presentation that we reviewed before break, shifting values of arrays, and kind of one of the last slides that was shown was the one here where we talked about an array of objects, and it might have blown your mind at showing some of the possibilities of an array. But we're going to kind of continue building on this principle and hopefully give some more insight. So this array is a one-dimensional array of points. And so another way that we can represent this data structure is what's called a two-dimensional array. So what I did here is I just made a spreadsheet real quickly of this exact same data set. And you can see by representing the columns as points and the rows as X and Y, I stored the exact same data set, right? So 3, 7 is 0.1, 4, 5 is 0.2, 8, 2, and so these are two equivalent ways of storing the same data. So we'll jump into this. The name of this presentation, Nested Loops, Algorithms, and Rectangular Arrays. Another way of talking about two-dimensional arrays because they're rectangular. Two-dimensional arrays are handy for keeping track of certain types of data. So this example, we have a one-dimensional array they call sandwich orders in line at a bodega. So they have 4 different types of sandwiches that can be made: turkey, ham, roast beef, or turkey. Wow. So why they have turkey twice, who knows, right? But maybe someone is ordering turkey twice, right? So these are orders for customers. So now let's extend that and say, okay, we want to keep track of each sandwich artist sandwiches. Okay, so I guess a sandwich artist is someone who makes sandwiches. And so if you have 4 sandwich artists, and we assume that each artist is going to be represented by the columns. So you have 1, 2, 3, 4 columns. And then on the rows, you have 3 rows of the types of sandwiches that the artist specializes in, right? So artist 1 is turkey, ham, and roast beef. Artist 2 is ham, turkey, roast beef. Artist 3 has 2 different kinds of roast beef sandwiches and 1 turkey. And the artist 4, turkey, chicken, and roast beef. We now have a two-dimensional array, or a rectangular array, right? And they say to traverse multidimensional arrays, we need a new tool. Well, it's not really a new tool. It's an old tool that we're going to be repurposing. So before we get into traversing multidimensional arrays, let's talk about nested loops again. I think everybody's maybe been introduced to this once. We're going to take an example called an inversion, which is a mathematical principle. So this definition says an inversion is a pair of numbers in which the first number in the list is greater than the second number. No elements are being moved or shifted, so you're not shifting anything around. You're just looking at the sequence of elements, and you're looking for where they're out of order, right? So before we jump into that, I wanted to show another example. Here's another definition of inversion from the wiki page. So it says computer science and discrete mathematics, and inversion is a pair of places of a sequence where the elements on these places are out of their natural order. Out of natural order means that they're not sorted. So the math definition, say you have a set or a sequence of values very similar to an array that has n values, 1 through n. And if the indexes to those values will always be so that I is less than j, right? Which is saying when you reference I, that means you have a value which is the first number and then all subsequent numbers, right? Because I has to be less than j, right? So if you start with 1, then you're looking for 2 through n. If you're looking at 2, you're looking at 3 through n. So if you enforce that and you find a value that is your value previous is greater than your value next, then the pair is called an inversion. The pair ij, which is the value that's pointed to by these indexes I and j, is called an inversion of A. The other thing, inversion numbers of a sequence is one common measure of its sortedness. So if you have lots of inversion in a sequence, it is not very sorted. If you have only 1 or 0 inversions, then your sequence is pretty well sorted. So we'll give a couple examples here. So let's start out with the example on the right. So you see a sequence which is a one-dimensional array, 4, 3, 2, 1. And so an inversion is a pair of numbers which the first number in the list is greater than the second. You see the first number here. You compare it to the second number. Is it greater? Yes, it's an inversion. So we now have one inversion. We now go to the next pair, comparing 4 to 2. Is 4 greater than 2? Yes, you have an inversion. Now you do the third. Is 4 compared to 1? 4 compared to 1. 4 is greater than 1. Yes, there is an inversion. Now you go to the next value, 3. And remember, we only want to compare to values after the index. So 3 now is going to be compared to 2. Is 3 greater than 2? Yes, you have an inversion. And so on, right? So hopefully you can see that this value has inversions for every pair. So this is a fully inverted sequence. Now, if you do this by yourself and kind of convince yourself that the array 3, 1, 4, 2 will print the following output, I want everybody to pause here and write the pseudocode for inversion. Use whiteboard arrays to organize your thoughts and to visualize the problem. And one thing that you can do is, if you take a sequence 1, 2, 3, 4, start there and say, how many inversions does that produce? All right, so let's do a real quick visualization of inversion. Here you see we have one example of a sequence 1, 2, 3, 4. This is in order sequence, and below you sort that sequence in ascending order. So 1, 2, 3, 4. You see that when you compare all these numbers and you go through your inversion algorithm, there is no inversions here. So this shows you that this is perfectly sorted. Now let's do one inversion. So we've swapped 2 with 1. So 2, 1, 3, 4, 5. We sort the sequence and we see that 1, 2, 3, 4, 5. If we compare them, there is one inversion. So that says this is almost sorted. There's one set that needs to be sorted. Can you see how many inversions there are in this sequence? 3, 2, 1, 4, 5. Hopefully you can quickly tell that, again, there's only one inversion. It's just inverted in a different location. And same with the example where the inversion is now with the first and the last digit, but there's still only one inversion. So now here's the pseudocode for the inversion. Surprise, surprise, we're using nested loops, so 2 loops inside of each other. The outer loop says for every possible first value and for every possible second value, if the first value is greater than the second value, then bam, you have an inversion. And now, if we want to implement that in Java, here's how we would do it. So we have an outer loop for int I is 0 to data length minus 1, and then we're looping through all the first values, right? So why did we pick data length minus 1? Look at the last value. Is there any second value to compare against? The answer is no, so therefore you don't need to look at that value. So you can stop before you get to the end. So you don't want to look at the last value. Then the inner loop, in order for you to compare all the second values, you have to start at the first value plus 1. So this means look starting at the value immediately to the right of the first value. And this one, you're going to be looking through the whole data set. And then you can compare those two, right? So if the data of the first value is greater than the data of the second value, bam, we found an inversion. Okay, so now we're going to talk about all the different types of arrays, and we're going to kind of go through for a specific type, a double, how you can build up different arrays going from a single value, right, a double. In this case, it's 1.5. If you wanted a one-dimensional array of doubles, you would use one set of brackets. And then to take that even farther to a two-dimensional array or a grid, you specify 2 brackets, and then you can fill in two-dimensional, right? So as many as you want in each dimension. And then keep on going. You can have 3-dimensional array, which here is represented by a cube. A lot of times in 3 dimensions we use height, width, and length. A dimension of a size, we can use X, Y, and Z for coordinates. Lots of good implementations. If you're doing any 3D graphics, you have 3-dimensional arrays all over the place. Now we're getting into the fun part, how to initialize a 2-dimensional array. So we have some new attributes that we got to point out. We already talked about wanting to show two brackets. So this is telling the compiler that we have a two-dimensional array. And then we have the new keyword. So you should have already been seeing the new keyword, which is used to initialize objects. Well, surprise, surprise, an array is an object or a reference type. So we've now initialized the two-dimensional array called ages with 2 by 3 grid, row by column, 2 by 3. What would this array look like? Maybe you can pause here and draw it on your whiteboard on what you think this array will look like and how it's indexed. Hopefully you drew something like this. Two-dimensional array is initialized with all zeros, and you'll see that you have 6 elements, which has 3 columns, 0, 1, and 2, just like a single, it's all 0 based. And it has 2 rows, 0 and 1. So this tells you a little bit about all the different things. Trying to initialize an array is a lot of baggage, and it's something that you got to get muscle memory on. But after you kind of get used to it, you'll follow the pattern. How are we going to implement here our access to an array? Let's do some examples. So we first want to access the first element of the second row. So remember, this is our array. It's called ages. It's got 2 by 3, the first element of the second row. So how would we get there? Everybody write it on their whiteboard, please. Hopefully you came up with ages bracket 1 bracket 0, the first element of the second row. Second row, row column is 1, first element, first column is 0. Now let's write something a little more complicated. How to access all the elements of the first row. So this is the one-dimensional array, which is considered the first row, which is a hint. Write it on your whiteboard. So here's what you should have come up with. The first element, which is the first row, is represented by a one-dimensional array, ages 0. So now let's build on that. To access all the elements of the second row, write down please. That was a lot easier. Now let's build on that even more, right? So we're going to use all our tools here, nested loops, two-dimensional arrays, and we want to predict the output of this method. So this method called print accepts a variable called grid, a parameter which is a two-dimensional array, and it's going to use that to loop through and print some output. Pause here and write on your whiteboard what you expect this output to be. First question, what is grid.length in the outer loop used for? Grid.length is up here. You can see that it's used for number of rows. You're going to traverse the rows first, and then what is the grid bracket I dot length referring to? I is the index used in the outer loop. If the index in the outer loop is rows, what is grid I dot length? Hopefully you came up with it's the number of columns. This is printing the number of columns in the inner loop and the number of rows in the outer loop. Let's bring up Eclipse. I coded this here real quickly to give you a better example. You have a main method. You have a grid. I called grid 1. I actually made 2 grids to show you the way that you can initialize grid. There's 2 ways. So this is a 2 by 3, 2 rows by 3 columns. So there's 6 elements. You can initialize these elements kind of manually, where you specify each value. Here I have the 6 values, 1, 2, 3, 4, 5, 6. And then I call the print method of grid 1. And as a similar exercise, you can also make a grid using implicit notation. So this is how you would initialize the grid. It's a little more compact. Both are the equivalent. You don't need the new keyword when you're using the implicit declaration here. And then I called the print method with the second grid, so they should come out to be similar. So here's the method that was there. So if I call this, you'll notice the first call I print 1, 2, 3. So column 1, column 2, column 3. Then you get down here and do a print line, which gets you to the second line, and then you go back into this loop and you print 4, 5, 6. So it's really kind of printing the rectangular array for you so you can visualize it. The last part here is a worksheet, and so you should be given a worksheet here shortly, and please go through and work through these questions. All right, have fun.